Hi, this is the YouTube channel for Math Contest Go Go Go. What I want to do for this channel is to build a platform for math lovers in order to make them discuss about different kinds of math problems. I will update a video about challenging problems every day. If you would like, please subscribe below. Okay. This week we are going to talk about Taylor series. Okay. So Taylor series is same to it's just the Maclaurin is expanded of Maclaurin series because it applies for every value. It is also for you to estimate a certain given equation like this way. Okay. The Taylor series is that if you want to calculate the equation at x equals to a, then it is given by this. So it is like this way. F4a 4x minus a. So it's like this. Well, after you find the Taylor series, you're able to find. The Maclaurin theory is just Taylor theory about a is equals to 0. So it's like the Maclaurin theory is just someone named Maclaurin plugging all the value of a into 0 and they are done. Well, I think possibly I can make some theory entitled on myself, and I say Taylor theory at a is equal to 1. Okay, you actually can try this way. You just give an equation like f1 plus f1x minus 1. You plug in every a equals to 1 and you give it a new theorem of your name. And you are famous. Okay. Well, let's give an example actually. So if we are going to talk about in x about x is equal to 32. So f32 is equals to 38 in 32. f32. So you list out the always. Yes, it's like this. Then f32 is negative 1, 32 square. f32 is 2 square minus. Okay. So here, you can use this way, all this to build up this equation. So let's give an example. So 1 plus 1 divided by 32x minus 32 plus minus 2 square x minus 32 square plus 1 332 square plus x and this is the Taylor's equation for it. Yes, the Taylor's equation for it is this. So this is just about how you make an example of Taylor series. Let's talk about something which is the hardest thing. Is called arrow bounds. What is arrow bounds? Arrow bounds is possibly the because the Taylor series approximation cannot be exactly accurate. It must have some differences. So, well, you know, okay. You know. Yes. So that's given you about how do you solve it, like on the third order or fourth order. Yes. Yes. Okay. Okay. Let's give you an example to see how to do this. So there's a formula like the language arrow bond is given. The arrow bond is less than or equals to m plus 1 squared. This is the equation for the arrow bonds. What do we call this? So we know that the Taylor series approximation is at x equals to a. So a is approximation of it. Yes, and x is something that you are required to find. Yes. So m is the maximum value of it's possibly the fnx, which is the last value or the maximum value on the interval. Okay. So let's give you an example. I will tell you how to solve it. The Taylor series fx is equals to sine x at 0. This is the Taylor series. X is equals to 1. So we get this is 2 pi minus 1. This is going to be 1. And this is n plus 1, which is the last. Let's say that it is going to be the third order. So this is going to be the 4. So we get that the formula is like this. 1 divided by 4 squared 2n minus 1 to the power of 4. 2 pi, sorry. So it's 5 point. This is going to be the final answer for it, for the arrow bonds. Let's give you one more example about how do we do the arrow bonds. Here we come to the end of this chapter, and I hope you have learned a lot. So see you next week. Bye. In fact, problems, they have many solutions, and my solution is only a part of them. If you have more challenging solutions, please comment below. And don't forget, I will also post my problems there. See you tomorrow!